Now that we have looked at the different forms of log, we shall move on to the 4 laws of logarithms. We will start with the power law. Why is it called the power law? It's because we are going to identify the power in the log form and we are going to manipulate it. So what we see here is log base a x to the power of r. So our power is r. So in the power law, it's stated that we can actually bring the power to the front and we'll have log base a x. Let's look at an example. So evaluate without using calculator, log base 2 8. So I have log base 2 here. Okay, and I can change my 8 to 2 to the power of 3. Why did I change? Why did I choose 2? It's because later I can bring the power to the front and I'll be left with log base 2 2, which is a special log form to make it 1. So bringing the power to the front, I have 3 log base 2 2, and log base 2 2 will give me 1, and I have my 3 in front, so 3 times 1 gives me 3. So now let's look at the second law, the product law. So in the product law, we know that with the same base, log base a, log base a, log base a, we can actually split out the product x and y, okay, by adding them together. So let's look at an example. I have two examples here, example A and example B. We'll start with example A. So in example A, we notice that all the logs here have the same base. They are all added together, so I can make use of the product law. So I'll put them in the same base. Okay, this is my x, this is my y, and my additional z. So I can actually multiply them together. 40 times 0.1 times 0.25. Okay, so from here I can use the calculator to find out the answer, but what I'm going to do is I just use a fraction. I'll cross multiply this 1, this 4, this 1, this is 1. So actually at the end of the day, I'll be left with 1 whole. And we know that if we log 1, we will get 0. So let's look at example B. We have log base 2 to square root 2. So what we have to identify is the base here so that we know how to split this up. So since my base here is 2, I'm going to split up in this way. 2 times square root 2. Using the product law, I'm going to split them up. Log 2 plus log base 2 square root 2. Okay, so I'm going to tease out the power in my square root 2. Log base 2 2 gives me 1. Okay, and using the power rule, I'm going to bring the power to the front. Log base 2 2 give me 1. So my final answer will be 1 plus half, which will give me the answer 3 over 2. Okay, now let's look at the quotient law. So the quotient law is like the product law, just that instead of x multiplied by y, we see here x divided by y, and all of them share the same log, same base. Okay, x is in front again. Instead of plus, we get the minus sign, and then y is at the back. So let's look at an example. Evaluate without using calculator log base 6 54 minus 2 log base 6, 3. So this question here has the same base to the log, and you see a minus sign. So this gives us the clue that we can use the quotient law. So let me write this down. Log base 6, 54 minus 2 log base 6, 3. Okay, so I have a problem here. My 2 is not behind my log, so I am going to use the power law and put it as a power. So log base 6, 54 minus log base 6, 3. My 2 becomes the power, so it becomes 3 squared. So now I have log base 6, 54 minus log base 6, 3 squared. So I can take my 54 as the x, and I can take the 3 squared as my y. So putting them together using the quotient law, same base, x goes on top, y goes below. So it's 54 over 3 squared. So I'll get log base 6, 54 over 3 squared, or rather 54 divided by 9 is 6. Since these two are the same number, the special log form tells us that they are equals to 1. Final answer. Now let's look at the fourth law, which is the change of base law. So this is a very powerful law as it allows you to change the base to the log. So for example, I have log base a, b. Okay, a is the base, and I would like to change it to c, for example. So I have a fraction here. I'm changing base a to base c. And now my b here will be in the numerator, and my a here will be in the denominator. So for example, if I have log base 2, 5, okay, and I would like to change the base to maybe 3. Okay, so my 5 will go on top, my 2 will go below. So this as simple as that. So what you need to know is how you express it, okay, in a fraction, and which one should go on top and which one should go below. Okay, so another useful thing that you would like to know is if I have log base AB and I want to have a simpler fraction, meaning a whole number on top. This is a kind of a trick. So I can actually change the base to b, which is the same number as the number that I'm logging. So log base b will give me 1, and then log base b, a, which is the a from here, will be at the bottom. So instead of having a log over another log, I will have 1 over log b, base b, a. Let's look at an example. So this question is to convert log base 5, 7 to common or natural log and find its value. So let's do a recap. Common log is log base 10, right? And we write it as LG. Natural log is log base E, and we write it as ln. Okay, so let's convert log base 5, 7 to common log first. So common log is base 10. So I write this down first. A fraction, log 10, base 10, log base 10 at the bottom. 7 goes on top. 5 goes below. Okay. So in short, it is LG 7 divided by LG 5. So if you key in your calculator, I have a calculator here, log 7 divided by log 5. I will get 1.2 . 0.0906. And if I correct it to 3 significant figure, I'll have 1.21. 3 sig fig. Okay, now let's look at the natural log and see if we get the same answer. So natural log means my base is e. So same question, log base 5, 7 is equals to log base e. Log base e. Okay, 7 goes on top, 5 goes below. So writing it in natural log form, I have ln 7 over ln 5. Now I'm keying it in my calculator. Ln 7 divided by ln 5. I will get like the same answer, 1.20906. Correcting it to 3 sig fig, I'll get 1.21. Magic. Okay, so now that we know all 4 laws, let's look at 4 different questions that test us on all the laws. The difficult thing, or rather the challenging thing about logarithms is that you need to look at the question and you need to figure out which law you can use to solve the question. So let's look at this. Evaluate ln 4 over ln 32 without using a calculator. So good thing is they share the same same base because they are both log base e. Okay, that's the meaning of ln, right? Okay. We would tend to look at the quotient law because you see a divide sign. But if you notice in the quotient law, I only have log base a, okay, and the quotient is here. But this question is actually a log divided by another log. So that means the quotient law is out. But what I notice is that 4 and 32 will have the same base. What do I mean by that? So let's look at this. Ln 4, ln 32. So for log, it will be good to be quite sensitive to the numbers. If you look at 4, I can actually change it to 2 square, right? And if I look at 32, I can change it to 2 to the power of 5. 2 to the power of 5 is 32. Okay, so now I can make use of the power law. I bring down the power, ln 2 over 5 ln 2. Now I have ln 2 here, and I have ln 2 here, and I can cancel each other out since they are in a fraction. And 2 over 5 will be my final answer. Question 2. Express 1 plus 2 log base 3 5 minus log base 3 1 over 27 as a single log. So this gives me a very big clue that I have to change all of them to the same base. So now my problem or my challenge is this one whole here. How do I change it to have the same log, same base? So what is this number? So to make this one whole, this number here and this number here has to be the same. So I'll have log base 3, 3 plus 2 log base 3, 5 minus log base 3, 1 over 27. Okay, so now my 2 is in front of my log, so I'm going to shift it into the log by using the power law. So log base 3, 5, my 2 come over here to be the power minus log base 3, 1 over 27. Alright, so now I have 3 logs with the same base and they are all separated by a plus sign and a minus sign. So this tells me that I have to use the product law here, and this tells me that I have to use the quotient law here. So I put my log base 3 down. Okay, so 3 and 5 square will be on top, and they'll be multiplied by each other because it is a log plus log. Okay, and 1 over 27 here will be at the bottom in the denominator using the quotient law. Okay, so let me repeat that. 3 log base 3 plus log base 3 pi square is at the top with a multiply sign, and then because of this minus sign, I'll use the quotient law. So this whole thing minus this, so this one goes to the bottom. Okay, so I have log base 3 times 5 square gives me 75 divided by 1 over 27. So if I key in my calculator, 75 divided by 1 over 27, I'll get log base 3, 2025. Question 3. Express y in terms of x. So I have common log y plus 1 equals to 2 minus half common log x. So the thing about this question is we have a little problem here because this is not in log form. So we'll probably have to change it to log form. Okay, so let's do that now. I have log, common log y plus 1 equals to this, which we need to find now, minus half common log x. How do we change 2 to a common log? So common log is log base 10, right? And now this number here is an unknown. And how do we find this number? We have to use the index form. So the index form we'll need to identify the base, and we'll need to identify the kite, which is the one on the outside. So my base is 10 and my kite is 2, so my number is 100. So this is 100. So I change 2 to common log 100. Okay, so here my half is outside, is in front of my log, so I'm going to shift it into the log. So common log y plus 1 equals to common log 100 minus common log x to the power of half. This is the power law. So then I have y plus 1 here, I have 100 here, and I have x to the power of half here. Okay, and all of them share the same log, which is the common log. So I will look at this first. These are two logs that are separated with a minus sign. So this tells me that I can use the quotient law to put them together. So I have common log here. Okay, 100 goes on top, and x to the power of half goes below. So log 1 plus 1. So since they are the same log, the same base, it means that y plus 1 is equals to 100 over x to the power of half is square root x. Okay, and this, oh wait, we need to express y. So we need to bring over the 1. So y is equals to 100 over square root x minus 1. This is the final answer. Okay, question 4. Given that log base 4 3 is equals to a and log base 4 5 is equals to b, express log base 75 16 in terms of a and b. Okay, so this question is quite obvious that we have to use this law called the change of base law. Why? Because I have log base 4 here, I have log base 4 here, okay, but I have log base 75 here. These are all different. This is different from the rest. Okay, so let me change it up. Log 75 here first, 16. Okay, so the change of base law tells me that 16 will go on top and 75 will go below. Okay, so what would be a base that you want to change to? 1, 2, 3, 4. You can change to any number, but let's look at the question. The question gives you the value or tells you that A is equals to log base 4, 3 and B is equals to log base 4, 5. So I would most likely need to use base 4. So I'm going to change the base to 4. Okay. So now I have log base 4, 16. Okay. And I have log base 4, 75. I will need to change log base 4 maybe to the same number here, because log base 4 give me 1, right? So I will have a 2 here. So I change log base 4 16 to become log base 4 4 square. Okay, and my bottom log base 4. How should I change the 75? 75 is 3 times 5 times 5, right? And I can actually use this log base 4 3, and I can actually use this here log base 4 5. Okay, so now let's use the power law to break down the numerator. So I bring down the power to log base 4 4, okay, over, okay, so since I have many multiple signs here, I'm going to break them out using the product law. So I have log base 4 3 plus log base 4 5 plus log base 4 5. Okay, running out of space here. So log base 4 4 is 1, so my numerator is just 2. Log base 4 3 is A, so I'll replace it with A. Log base 4 5 is B, so I'll replace it with B plus same thing B, and my final answer is 2 over A plus 2B.